Hi, welcome back to another video, and today we're going to be looking at factorising. In fact, we've already looked at factorising, but today we're going to be looking at it in a lot more depth, okay? So stay tuned, try not to get bored because I'm going to be doing quite a few different equations, okay? Let's get straight into it and have a look. Okay, so the first one we're going to do is x cubed plus 2x. Now, to factorise, I want to find something that can go into both of these two guys here. And we know that there is an x here and there's an x here. So, what can we do? We can say that that is actually the same as going x squared plus 2. Okay? And that's about as far as we can go, so that one is done. So the next one is as follows. Okay, so we're going to have x cubed minus 5x. Now, remember to pause the video if you want, just so that you can give it a go yourself, but if not, then just listen up. Okay, so here we got basically the same thing. Super easy, super simple. We got an x here and we got an x here. Then they must be able to come outside of our brackets, as they can both go into this equation. So we've got x times x squared gives us x cubed, minus 5 will give us minus 5x, and that will give us our answer. Again, very, very easy. Okay, I'm slowly going to ramp this up so that you can really start to understand potentially the harder parts of factorising. Right, let's try another one. So again, if you haven't seen the previous video, go check it out because this is just building upon that. So this time we've got x cubed minus x squared minus 12x. Now, so far in my series, so far in my videos, I said about, what does a quadratic expression look like? It looks like ax squared plus bx plus c. And if you saw the previous video, you would know how we can factorise that. Okay, at the moment we now got something which looks similar but ever so different. What I want to be able to do is take it from this sort of equation to this sort of equation. So the question is, how can I turn x cubed minus x squared minus 12x into the quadratic expression that we are familiar with? Well, I can see that if I took out an x from each of our expression at the top here, we would get our quadratic expression that we are familiar with. So let's do that. We can take x on the outside, so x comes outside of our brackets, and we know that if we multiply by x squared, we get x cubed, minus x, we get minus x squared, and minus 12, we get minus 12x. So we've got our expression now, and in the middle here, we have got the quadratic expression that we are all familiar with, okay? And so then it's a simple process of factorising our quadratic expressions. So what do you do now? Well, I know that a is equal to 1, so there's 1x squared. So that's a, that's b, that's c, a, b, c. We've got a, b, c, okay? We know that b is equal to negative 12. Sorry, c is equal to negative 12, yeah? So if I multiply a and c together, that gives me negative 12. Okay, so what I then want to do is work out what is b. Now, b is equal to negative 1. Okay, great. So what is the process now? The next process would be to find out what two numbers can multiply together to get negative 12, but add together to get negative 1. Okay? Now have a little think for yourself. What could that be? What two numbers could those be? Now, I'm thinking negative 4. What I would probably recommend you do actually at this stage is sort of think of all the scenarios which could multiply to negative 12. So we know that 12 times negative 1 could be it. We know that negative 12 times 1 could be it. We know that, for instance, negative 4 times 3 could be it, etc. Okay? So just go through those stages one by one and work out all the numbers, or all the combinations of numbers that could multiply to make negative 12. And then you go through each of those numbers and find out which of these numbers, or two numbers, therefore add together to make -1. So you go 12 plus -1, does that equal -1? Well, no, obviously not. That's a stupid suggestion. But as you go through it, you'll find something like, -4 plus 3. You know, I learned this at primary school. This is super simple. I can do -4 plus 3. That equals -1. So we know that this must be the one that we want to use. Okay, -4 and 3. And so at that stage, you just want to rewrite our quadratic expression. Okay, so before we got x squared using these two numbers. So we've got x squared. Now the b's, this becomes our new b essentially. Okay, so x squared minus 4x plus 3x. So remember to put x at the end of them because they're just in our b column with just a single x, and then -12. Okay, and remember this is all inside our bracket still because we've got this that's all being multiplied by x. And then as before, we just want to make it simpler and block these out. Block these two separate parts of our expression in the middle into separate expressions. So x squared minus 4x can be essentially factorised into x minus 4, and then we can have plus, we know 3x minus 12 if we want to factorise that, but we know that 3 goes into both of them, so we go 3x minus 4. And hopefully these two guys in the brackets will be exactly the same, and therefore we can rewrite this expression as x plus 3, x minus 4. Okay, and that should give us the answer. I mean, if you've got x plus 3 over here and x minus 4 over this way, that doesn't matter, but that is the answer to that equation. Okay, and don't forget this x at the front of the expression, which we took out right at the beginning here. Okay, right, what is next? Let's try another one. Okay, let's make it even harder. How about something like, well, not necessarily massively hard, but we'll try this one. X cubed minus 4x. Okay, so this time, this may be quite scary. I mean, I can't just turn it into a quadratic expression, ax squared plus bx plus c. I can't just transform it into that expression. So instinctively, it could look a little bit scary, but try and give it a go yourself before I do it. Just use some of the principles that you already know how to apply and just go try and work through it logically. But if you can't do it, not a problem. So this is what you should do. First of all, I know that x can go into x cubed and minus 4x. So let's do that. So we've got x squared minus 4. Okay, so we've got x on the outside, and we've got x squared minus 4 on the inside. Okay, now I know that 4 is the same as saying 2 squared. Okay, so we can get x squared and 2 squared in the middle. So let's just write that out again. So we've got x squared minus 2 squared. As I just said, we got 2 squared is the same as 4. Okay, so ultimately then we're trying to work out a way that we can factorize this. This isn't the end of the equation. Like many of you may stop here going x squared minus 4. We can't stop there because there is a way in which we can multiply two brackets here. If we know that if both things are squared, then the whole bracket should be able to be squared here. Okay, so if I then take x and go, what can I multiply x by to get x squared? Well, I know that I can get x times x. Okay, now if I want to get 4, I know that I can multiply 2 by 2. Okay, so we can put 2 in here and 2 in here. So I got x squared. So then, sorry, I got x squared and I got 2 squared. Okay, but here's the problem. What symbols do we use? Now, of course, if I just put in positive symbols, okay, this is going to give us the wrong answer. That will give us x squared plus 4x plus 4. Okay, that's not what we've got here. What happens if I just put in negative symbols, because we've got a negative here, maybe this will work. This will give us x squared minus 4x plus 4. Okay, still not right. So potentially then we should be thinking about putting in positive symbols and a negative symbol. So we mix up the two symbols, and usually when you've got an expression that looks like x squared minus 4, you've probably got something with a positive and minus symbols, okay? Positive and negative symbols. So this would give us x squared, so multiplying those two out, x squared minus 2x plus 2x, and minus 2 plus times 2 is negative 4, okay? And of course the negative 2x and the positive 2x cancel out, leaving us with x squared minus 4, which is the same as x squared minus 2 to the power of 2. So we can therefore put in x, this equals x, x plus 2, x minus 2. Okay? Right, let's try something really difficult now. For those of you who want to super stretch yourselves and ultimately become the best mathematicians possible. So this time we're going to have 4x to the power of 4. Exciting. Negative 13x squared. And let's add 9 to the end of that. Yeah? Okay, perfect. So, in this situation, what you should do is really apply the same principle that we have had all along of ax squared plus bx plus c. Now, the way that I find this easiest is to transform, as I said before, this equation into our quadratic expression. But how do we do that? I mean, we can't just take out an x here because of course the line doesn't have an x, and we can't just, get rid of numbers because we don't like them. It doesn't work like that. We have to still work with what we've got. And so what I always find easiest is to try and put a placeholder in place so it becomes familiar with our brain, so that when we do the expression it's much more obvious what the hell we're doing. Now that may not make any sense to you, but watch what I do here. So let's say we call x squared, so we're just sort of we are making a little transformation. It's a little bit like magic, I suppose. A bit boring magic, but still a little bit magical. If I say x squared, okay, is equal to, let's say, u, okay? It's just u. So whenever I use u in my expressions, in my equations, okay, that's now going to be x squared. We're just going to say that u is x squared. It's like saying, I don't know, you could call this pen is a giraffe. I don't know. We're just giving it a name. It's not necessarily the giraffe, but we're just going to call it a giraffe, okay? I don't know why, but it's a giraffe. In this case, u is x squared, okay? I don't know. I'm David Beckham. I have no idea. It's just a name, okay? U is x squared. And so I'm going to then transform this expression here using u. So we know, if you remember our video on the index laws and the laws of indices, we know that if we said something like x squared to the power of 2, all we're really doing is multiplying this power by this power, so that will give us x to the power of 4, okay? Super simple. And I'm going to apply that same thinking into this expression now. So, watch this. If I said 4u, well, 4u using this would be 4x squared, okay? So, that is 4x squared, okay? Those are the same things. 4u and 4x squared are the same. Now, if I did 4x squared to the power of 2, that equals 4x 4, which is this number up here, okay? Same thing here is if I go 4u squared, that would be equal to this, which is therefore equal to that, okay? So 4u squared is equivalent to 4x to the power of 4, okay? And how about the next one? So we've got 4u squared, which we now know is equivalent to 4x to the power of 4. We've got negative 13, and we've got x squared in there. And as x squared is equivalent to u, we can just say it's negative 13u, okay? And then finally, we've got a positive 9 at the end, which we don't need to do anything to because it's by itself. And look what we've done. All of a sudden, and super magically, we have created this quadratic expression, ax squared plus bx plus c. 4u squared minus 13u plus 9. Okay, so let's just deal with this equation as we would always do, okay? So, what is 9 times... Well, first of all, we need to work out what's a, what's b, what's c, and we know that 4 is a, b is negative 13, and c is 9. Now, c equals 36, okay, and b equals negative 13. Okay, and so as I would always do, I would work out what can multiply together to make 36 but add together to make negative 13. Okay, first of all, let's have a look at the things that can multiply together to make 36. Now, we know that, for instance, well, we just did one, didn't we? So we did 9 times 4 would equal 36, but we also know that negative 9, negative 4 would equal 36. Remember that if we multiply together two negative numbers, we're going to get a positive result, okay? So minus 9 times minus 4 will give us 36. Now we need to look at probably the negative numbers, and we know that because we need two numbers that add together to make a negative number, okay? So we're probably looking at something like negative 9 and negative 4. And if we have a look at this one, for instance, here, and we go minus 9 times minus 4, that equals 36, so that's checked. And minus 9 minus 4 does equal negative 13, so that is checked too, okay? So we know that this is what we're going to replace b with, and that's what we're going to do now. So we can rewrite this by going 4u squared minus 9u, remember to use our u's here because we transform this into u's, minus 4u plus 9. Okay, so now we've got our new sort of expression where we transform the b's into, well, I could say the b, which is the 13, into two separate b's essentially, and we've got our new expression. And then, as I said before, deal with each of these guys separately. So we've got this broken down into u. So we're going to factorise this half of the expression, so u is common to both 4u squared and negative 9. So then that will give us 4u minus 9. And then here we've got basically minus 1 4u negative 9, because negative 1 times 4u is negative 4u, minus 9 times minus 1 is positive 9, okay? And then, so that will equal u minus 1 4u minus 9, okay? So that is it broken down in terms of that factorization, but we have not finished here, okay? Be very careful, and this is where a lot of people really do make mistakes, because they think, I've done it, it's all been factorized, it's all in its nice little brackets and it looks pretty, but it's not finished. And you know, this should start ringing alarm bells. We've got u here, where's our x gone? And the x is still locked away up here as an x squared. So, well, x squared equals u. So, we haven't finished. And what we need to do is transform these into x squared. So really what we have here is, I'm going to change the colour of the pen, but just know that I'm just continuing from where we were essentially. I really need to get some new pens, God. These aren't very clear, I'm sorry. Okay, x squared, so we've essentially got x squared minus 1, because u is x squared, and we've got 4x squared minus 9, okay? And then, like before, all we want to be doing is transforming this into well, what we want to be doing is making sure that there are no other ways that we can sort of expand this further, okay? And the way to do this is to see whether or not we can change each of these expressions into squared expressions, okay? Now, x squared is already a squared expression, so we don't need to worry about that. But x squared, don't worry about the negative symbol, but the negative symbol's in there. And the 1, though, can be... I'm changing this pen again because it's not very clear. The 1 can be squared, because 1 squared is just 1. Don't worry about the negative part of it, but 1 squared, so 1 times 1 is 1. And then 4x squared, well, the x squared is already a squared expression, but the 4 isn't squared here. Obviously, we've got 4 times x squared is essentially what 4x squared is telling us. But we can change 4x squared into a squared expression by saying 2x squared. By putting it in brackets, everything within the brackets is squared. So 2 squared times x squared will give us 4x squared. And then again, we've got negative, don't worry about that symbol, but if we have 3 squared, that will give us 9. So we have got 4 squared expressions within our brackets here, which means we can expand. Okay, I'm going to have to go to a new line here. So how can we expand this? Well, we know that if we've got a negative expression and like the same principles that we had before, we can just go x plus 1, x minus 1 will give us x squared minus x plus x negative 1, which cancels out to being x squared minus 1, which is exactly what we've got here. So that's correct. And then over on this side, it does look a little bit more tricky, but don't worry. We know that it's going to be essentially the same principles that we just applied a second ago with this. We know that there's going to be both 2x and 2x inside our brackets because that's exactly like where the x's are, and 2x times 2x gives us the 4x squared that we're after. Perfect. Now we don't want any middle expression with a single x, so we know that it's going to have to be positive and minus symbols in there, and we know that 3 times 3 is going to be 9, okay? And that will give us our final expression, x plus 1, x minus 1, 2x plus 3, 2x minus 3, okay? So that should be about it, and I think that should help you cover the majority of the difficult expressions, especially if you're doing A-level maths. And yeah, I think this clever little trick up here with x squared equals u will help a lot of you when you come across these seemingly impossible quadratic expressions, okay? So if you have any questions, just let me know and I will get straight back to you. Thank you very much for watching.